Backpropagation is a useful mathematical approach for boosting prediction accuracy in data mining and machine learning. It is also a learning algorithm used by artificial neural network to compute a gradient descent with respect to weights. Backpropagation is used for training federal neural network, technically a very essential concept in neural networks. Backpropagation can help data scientists understand how to modify the overall behavior of a neural network. In simpler terms, we can also call it error correction. Stay tuned if you want to know more about the need and functioning of backpropagation, and we will break it down to you in this session without any further delay. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions, and I will respond to your comments.
Hello everyone, my name is Shambhavi. Hope you all are doing well. So today we are going to start and learn about this respective topic, that's the backpropagation. So this particular tutorial covers all the respective things under the topic, which is backpropagation. Before moving towards the agenda or anything something like that, I just wanted to let you know first of all that what does this backpropagation is and in which technology it belongs. Okay, what is the main essential thing under which this backpropagation comes? So if I talk about neural networks, okay, if I talk about neural networks, so that's the particular place where this backpropagation comes under. So neural networks is a topic that is in the deep learning, and under the neural networks we have this respective algorithm, that's the backpropagation, right? So this is how it's actually classified, and this is how and this is the respective topic under which the backpropagation tutorial comes, right? So great, hope I'm clear with that it's a part of the neural networks. Okay, now let's jump forward and let's learn about the agenda, that what's the agenda that we are going to follow up here right in this respective tutorial. So let me take you to that respective place. Okay, here we are. Okay. Whenever you are starting with a topic, okay, whenever you are starting out with any of the respective topics, always the very first thing is to learn that what that respective topic is. Now, in particular, if I take up here the backpropagation, so my very first topic for the discussion would be what is backpropagation. Okay, I did already told you that under which respective thing, under which respective technique this backpropagation comes. So it's under the neural networks, and neural networks are under the deep learning. So it's a sort of that respective thing only. But what backpropagation actually is, that will be letting you know in this respective one, that is what is backpropagation. Now, when you have learned that what backpropagation is, very clear with that, what it is, and in which respective technologies this is completely used, everything is very much clear and very much sorted. Now, we will be learning that how this algorithm actually works. I did already told you that backpropagation is an algorithm, right? That is used up in the neural networks, that is used up in the feed forward networks, right? Now, into that particular case, how does this respective algorithm works? What are the things that you need to take care of? And what's the diagrammatic view of the working of this algorithm? How many layers we are having? That all topic we will be covering under how does the algorithm works. Now, when do you learn about the working of this respective algorithm? There's one more term which comes, that is a forward propagation. Backpropagation, you are aware right away, you learned about backpropagation. Then there is one more term which comes as forward propagation. So we'll be differentiating a little regarding the back and regarding the forward propagation. Not too much, but a little, okay? Then after learning about these, we'll be learning about the feed forward network. A very important term, a very important term to learn about actually, right? So we'll be dealing with the feed forward networks. Then we as well have some categories. We as well have some types of back propagation networks. We'll be seeing those respective types of the back propagation networks as well. So there are in total two. So those two will be discussing up right in that respective point. Okay. Next, we'll be learning about the key points of the back propagation. That what are the key points, the important points in the back propagation. And now, as I always say, when if we are learning about any respective thing, you are giving your 40 to 45 minutes in learning of this respective thing. So yeah, you shall be aware of that what are the advantages, that why are you learning up this respective technique. Already there are many things which are already introduced in the neural networks, in the deep learning. Then why this back propagation was introduced, and what is the advantage of using up this backpropagation algorithm into your models. Now, after learning the advantages, why are these many algorithms being made, right? Now, some or the algorithm is made, that perspective is having the advantages as well it has some disadvantages. So to overcome that disadvantages, a new one is made. Then again, if you are having up a respective topic, if you are having up out a particular topic or any algorithm, so surely there are gonna some or the either disadvantages, right? So I'll be letting you know that as well, that what are the cases where you shall not or where you can't use up the back propagation, and what are the cases, what are the situations, what are the models where you could use up the back propagation. So we'll be ending up this tutorial while covering up all of these respective things. Okay, so great. Hope I am clear with what's the agenda that we are going to follow up into this respective tutorial. Now, I did have a very long talk. Let's move forward with the very first topic of ours. Let's understand what is back propagation. So, first topic which we go ahead with, what is back propagation? First thing I did mention previously as well, I would again repeat that backpropagation is an algorithm which is essentially used, which is an essential part in the neural net training. When you are dealing with the neural net training, so in that respective case, backpropagation is the algorithm which plays up an essential part. Very important thing. Okay. Now, you got to know that what is the respective training or what is the respective technique in which this backpropagation algorithm works, right? Now, what backpropagation actually is. Okay, when you want to obtain the previous iterations, okay, the previous iterations, whatever have been happened, when you want to achieve that, when you want to obtain out those respective previous iterations, for what? What's the reason for obtaining that out? For the fine tuning of the error rate. Whatever the error rate is there, for the fine balance, for the fine tuning of that error rate, you want to obtain out the previous iterations. That is called as back propagation. Okay. So it's a process in which you obtain out the previous iteration. The previous iterations is as well called as the epoch. If I spell that out, so it's EPOCH. Okay. Now, if I say epoch or if I say previous iterations, yeah, both are of the same thing. Okay. So the process in which you obtain a previous iteration for a fine tuning, for a fine balance for the error rate. Now, if I say weights of a loss or if I say error rate, again, both are the completely same thing. I would again repeat, if I say weights of a loss or if I say error rate, both are completely the same things. Okay, so please make sure whatever the terms I use up in the particular tutorial further as well, so you can relate out with that. Okay. So for the fine tuning of the weights of a loss, which is based upon the neural network, neural net. So in that respective case, the back propagation is the process which we use out. Okay. So condition goes for the back propagation is that whenever you want to obtain the previous iterations for the fine balance of the error rate, then we use up the back propagation. Now, which is based on the neural net, so that we already are aware of that for the neural net training, back propagation plays up a very essential role. So at each and every place, it's not mandatory to mention that out, because we are very well aware right now that back propagation plays up a important, essential part in the neural net training. Okay. Now, why are we actually doing up a fine tuning or a proper tuning of this weights of a loss? Why we are doing up these things? Okay, so the correct and proper tuning of the weights, actually what it does when you do up the correct and the proper tuning of the weights, it helps you to lower up the error rates. Lowering the error rates, I hope you are like clear with that. Lowering the error rates are gonna give you the good model, right? Are gonna give is gonna actually increase the generalization of your model, right? So in that case, it's important for us to lower up the error rates whatever we are having up. So that lowering of the error rates can be actually, we do that with the correct and proper tune. So, for why we apply up this correct and proper tuning of the weights, so we apply that to lower the error rates of our model. And the model is made reliable by increasing the generalization. And how do we make up the model reliable? Means more stable. So we make that more stable by the increase of the generalization. So when we give up the increase in the generalization, so our model is made more reliable, more stable. Okay. So when I in the back propagation definition, I told you that that it's a process of obtaining the previous iteration of the fine tuning for the weights of a loss, right? I did mention for the weights of a loss. So now why is that for the fine tuning? So because correct and fine tuning, correct and proper tuning of the weights help you to lower up the error rates. So for lowering of your error rates, for getting your model more better, the correct and proper tuning of the weights is done. Okay, and for increasing and making your model more reliable, more stable, you need to increase up the generalization of that respective model. Okay, so great. Hope I am clear with what is back propagation. Let's take a very quick recap whatever we studied. So we studied that back propagation really plays a very important part in dealing with the neural net training. Secondly, we learned that what back propagation actually is. So that's a process in which you obtain of the previous iteration of the fine tuning for the error rate, which is based on the neural net. And the correct and the proper tuning of the weight, it completely helps you to lower up the error rates, and whatever the model is there, it is made reliable by increasing of the generalization, right? So great. Hope I am very much clear with these respective things to you, that what is this back propagation, why we do the fine tuning, and all of those respective things. Now let's move forward further and let's study about the second topic of R under this respective tutorial. So now next our second topic of discussion is that how does the back propagation algorithm works. We did are very well aware now that what back propagation algorithm is, right? What's the use and what is that actually? Now let's learn about the working. Okay, so let me take you to the further deck here. Before moving forward with that, what are the algorithm? What is this algorithm? How it works? So firstly, I just wanted to let you know that in the back propagation, we have three main layers. Okay, three main layers are there in the back propagation, and the complete working of the back propagation algorithm takes place in respect to these three layers. So the very first layer is your input layer. The second one is your hidden layer. And the third one is your output layer. The three respective main layers which you have up in the back propagation. Okay. Now, so here what is the case is that in the input layer, in the hidden layer, and in the output layer, whatever the functioning, whatever the things are there, simply all of those works in respective to these three of the layers only. Let me give you a very quick idea of this respective diagram, and then I'll be taking you forward and the complete idea for the algorithm working. So have a look here on the on the left hand side. You have the input layer above which the number 1 is written, and that is your input layer. Okay. Next, when you move forward where the point number 2 is written, that's your hidden layer. And when you move towards the point number 3 where 3 is written, so above that it's the output layer. So the first one is your input layer, the second one is your hidden layer, and the third one is your output layer. So these are first of all the layers, these are the respective layers, the three main layers for the working of your algorithm. Okay, first of all, this is very much clear. Next, from the input layer, in the input layer, we have the denotions for the x. Okay, and when this input reaches up till here, so here we have the like alphabets which are written as W, and here we have the final ones. Now, actually, there is some difference in the desired values and in the actual values also. So yeah, I'll be discussing through all of those respective things. But first of all, see, what are the input layers are? They are in complete black. Right? What are the input layers we are having? Those are in the complete black color. Now, if we talk about the hidden layers, so all my hidden layers and this respective ones as well, these all are in the dotted forms. So this dotted form is depicting, it is actually showing that whatever the layer I am having up here, it is completely the hidden layer. Have a look. All of these are dotted. And now when I'm talking about the output layer, so yeah, that's again in the black and the red color. Okay, so yeah, that's a thing right here which we are having. Okay, great. So that's the red one. This is the back propagation output layer. Okay, so yes, this is the respective idea. This is the respective case which we have up here for this algorithm. Now let me take you further for the discussion of this, how this algorithm works. Now, whatever the image which we just saw right a few seconds before, what does that respective image tells us? What does that respective summarizes? What is the functioning of the back propagation? Let's discuss that out. Now, whatever the input layer which we saw up here, that input layer receives the x that I told you here in the this circles which are made up here. So this input layer receives up the x. Further, the input is modeled using weights, that is W. Now, whatever the inputs we are having, that are modeled. Whatever the modeling has to be done, whatever the sort of functions or the things have to be done, they are modeled using the weights. And that's the reason here into the circles we did wrote up W. Fine. The X is your input. After that, that respective input has been modeled using the weights with the W here. Okay. Next, each hidden layer calculates the output and data is ready out the output layer. Now, whatever the hidden layers we are having up, each and every hidden layer calculates the output. Okay, and whatever the final output we are having, that respective one is shown to us into the output layer. So here the hidden layers which you are able to see, the dotted lines which you are able to see, all of these respective things, these are calculating up the output. Now, after the calculation of the output, on this output layer, the final output, whatever is there, that respective output is to be displayed. Okay. Further, difference between the actual output and the desired output is known as the error. Now, that thing I did already mention up. that whatever is your uh, like actual output and whatever is your desired output, okay, that respective one is known as the error. The difference between actual value and your desired value is known as the error. Fine. Go back to the hidden layers and adjust the weight so that this error is reduced in future runs. Now, after this, go back to the hidden layers, whatever are there, and adjust them using the weights. Why? So that whatever the error is there, that is reduced up in the further runs. Error means the difference between the actual and the desired output. So how to reduce that out? So for reducing, what you do, you simply go to, again you go back to the hidden layers, adjust out those respective hidden layers in a form that for the future runs, there the whatever the error is, it means that whatever the differences in the desired value and in the actual value, that gets reduced up. Okay, so for that this respective hidden layers are actually like edges, and the process is repeated till we get the desired output, and this respective procedure is repeated up till the point you get out your desired output. Okay, so for getting up your desired output, till the time you don't get it out, this respective procedure is completely repeated. The training phase is done with the supervision. Once the model is stable, it is used up in the production. So whatever the training phase is done, that is done with the complete supervision, means that like complete carefulness and all those things. And whenever the model is stable, reliable, it's completely used up into the production. Okay. So how does this work? The input layer receives the X. After that, the input, the X which has been received, that input is being modeled using the weights, that is the W. Then your hidden layers actually work and they give up the output, and that respective is gone up, is shared up here into the output layer. Now if you get up any difference between the final between the actual value and between the desired value, so that respective difference is called as the error. And next, for reducing up that respective error, what we do, we simply try to adjust up these respective hidden layers, whatever we are having, we try to adjust those hidden layers so as to get up the complete, so as to reduce up that respective error, so as to reduce up the difference between the actual values and the desired values. Okay, so the first one here is your input layer, the second one is your hidden layer, and the third one here is your output layer. So as I did as we mentioned it, that in the back propagation you have three main layers. Okay, that were your input layer, your hidden layer, and your output layer. So I would summarize that out very quickly, that whatever your input layer is, that it's there, it receives the X. Okay. Next, your input is modeled using the weights, that is the W. After that, each hidden layer calculates the output and the data is ready at the output layer. The difference between your actual output and the desired output is known as the error. And go back to the hidden layers and adjust the weights so that this error is reduced in future runs. Okay, so this respective procedure is applied up till the point we get the desired output. The training phase is done under a supervision, and once the model is stable, it's completely used up into the production. Okay, so hope I am clear with this, very clear with this to you, that how does this algorithm actually works out, what are the main layers, and how are these actually categorized. I hope that you're clear with this diagram as well, and with this summary as well, which I did mention up here. Right, so this is how this respective algorithm works, and this is how this actually takes place, this is how the error is reduced, and all of these respective things. Okay, Next, let's move forward to the third topic of our discussion under this backpropagation tutorial. Now, let's learn about that what is backpropagation and what is the forward propagation. Okay, backpropagation, you are already aware that what is that. But with respect to the forward and the backpropagation, what's the minute thing which comes there in between? Let's learn about that particular thing. So here we go. If I talk about the back propagation and if I talk about the forward propagation, so what happens in the forward propagation? It is a process to move from the left to the right in a neural network. Left to the right means from the input layer to the output layer, and that's known as the forward propagation. So that's completely a process in which we move from the input layer to the output layer. It means from the left towards the right in a neural network. That's called that's called a forward propagation. Okay. Now, secondly, what if about the back propagation in the same manner? Back propagation. So when you move forward from the output layer towards the input layer, it means when you move from right to the left, that is called as your backward propagation. I would again repeat it out. Moving from moving from right towards the left in your neural networks is known as the backward propagation. Okay, left to right is your forward and right to left is your backward. Now left to right I did already mention up a few minutes before into the same diagram. I did told you that onto the left we have the input layer and onto the right we have the out. Have a look over this diagram once again. Onto the left, that is onto the point number 1, that's your left, and into that you are having the input layer. Where the point number 3 is there, that's your output layer, and yes, obviously that's onto the right hand side. So here in the diagram, have a look for this as well, back propagation output layer. Okay. So what happens that when you move from the input towards the output, from left towards the right, that's your forward propagation in the neural networks. And when you move from the right towards the left, that's from your output to the input in the neural network. That's known as the backward propagation. Okay. Now, for the intermediate variables in a neural network, for the calculation and for the storage from the input to the output layer. Right here, what we meant up is that why to move from output to the input or input to the output. So it happens that for the intermediate variables in the neural network, what are the intermediate neural net? What are the intermediate variables? The variables which are in middle. Okay, whatever the variables you are having in the intermediate, and even for the calculation and for the storage from the input to the output layer, these respective things are taken up the place. So for the storage from input to output, for the calculation from input to output, these respective back propagation and the forward propagation takes place. Okay. So hope I am clear with what is backward and what is the forward propagation. How do these things take place and how are these respective things making up and what is the use of these things up here. Okay, so great. Hope I am very much clear with what is back and what is the forward propagation. So now let's learn about that. What are the types of the back propagation network which we are having up here. Okay, so let me take you forward here. Great. In the very starting as well, I did mention of this one thing that we are having of the two types of back propagation network, right? So the very first type of the back propagation network is a static back propagation. And if I talk about the second type, so that's the recurrent back propagation. Okay, the static back propagation and the recurrent back propagation. So what happens up into these respective back propagation networks? In the static backpropagation method, what happens is that what are the static input data is generated, okay, that is mapped with the static output, okay. Whatever the static input data is being generated, whatever the static input is being generated, that is mapped up with the static output. So this is the thing which happens up in the static back propagation. Next, if I talk about the recurrent back propagation, so what happens? So into this, what happens is that uh, this recurrent back propagation is conduction till the certain threshold is met. It basically is conducted, it basically like works till the point a certain threshold is met. And after that, the error is calculated and it is propagated backwards. So in the recurrent back propagation, what happens? That the condition that it is conducted till the certain threshold is met. After the meeting of the certain threshold, the error is calculated and then it is propagated backwards. So these are the things. This is how the recurrent back propagation works about. A certain threshold is met, a certain condition is met. You could say, I'd say that out in simple terms. Okay. If you want to say this certain threshold is met in the simple terms, so you could simply add till the certain condition is met. Okay. So after this, the error is calculated and it's propagated backwards. Fine. So for the static back propagation, in this method respectively, the mapping of the static input is generated and in the static output. Okay, mapping of the static output generates the static output. So that happens in the static back propagation. And for the recurrent back propagation, the conduction, it is a conduction till the certain threshold is met. And after this, the error is calculated and it is propagated backwards. So till to a point a certain condition, a certain threshold is met, in that the recurrent back propagation is conducted, and after the certain threshold is met, after certain condition is met, the error is calculated, whatever the error is there. Now again I would say error means it's not the syntax or the indentation errors. Error means up here that till the point the difference between the output, the difference between the actual output and the desired output is known as the error. So same goes up here as well, that whatever is the difference between the desired output and between the actual output, that's the error. So after the conduction till the certain threshold is made, the error is calculated, that is the difference is calculated between the desired output and between the actual output, and it propagates backwards in the recurrent back propagation. And nothing sort of like this happens in the static. Simply the static input is generated, and that static input which is generated, that is mapped up towards the static output. Simply this happens up in the static back propagation, right? So great, hope I'm clear with that what are the two types of back propagation networks which we are having up here, and how these respective back propagation networks actually work about, and how do these respective things take place. I would once give you a recap that there are two types of back propagation networks. The first one is your static back propagation, and second is your recurrent back propagation. So what happens in the static back propagation? That in this respective method, mapping of a static input generates the static output. And in the recurrent back propagation, what happens? That in the recurrent back propagation is conduction till the certain threshold is met, and after this the error is calculated and propagated backwards. This is what happens up here in the types of back propagation network, right? So hope I am very much clear that what are the types of backpropagation and what are the types and what do these respective types mean and what do they do. Right, hope I'm clear with that. Let's move forward with the next topic. Now let's learn about that what is a feed forward network. Okay, what is a feed forward network? Let's learn about that right here. So first of all, let's learn that there is one another name which is actually there for the feed forward network. Okay, so that respective another name which I'm talking about is multi-layered network, MLN. So if you say feed forward network, uh, or if you say multi-layered network, both the things are absolutely the same because it's the another name for the feed forward network. Okay, now uh, first of all, it's one of the very type of simplest type of the artificial neural network. Okay, feed forward network is one of the very simplest types of the artificial neural networks. Okay, further, what happens that the networks, this respective network is known as a feed forward network. The reason for that is the data travels forwards in the in through input node, hidden layer, and finally to output nodes. What happens that whatever the data we are having, that travels first of all into the input node, then it goes to the hidden layer, and finally it goes out to the output node. And this is the reason that why these networks are called as feed forward networks, because whatever the data you are having, whatever data you are having, that travels in the neural networks. N is for the neural networks. Okay, so whatever the data you are having, that travels forward in the neural networks first of all through the input node, then comes your hidden layer, and then finally it goes to your output node. So as we saw into the back propagation algorithm, that first of all it was going into the input layer, then that was the hidden layer, and then it was your output layer, right? So in the same manner, this feed forward network is known is like that because whatever the data you are having, that respective data travels forward in the neural networks through the input node, then comes your hidden layer, and finally your output nodes. So now this respective one travels in a very simple path, right? Travels in a very simple way, and that is the reason as well why it is said as one of the simplest type of artificial neural networks. So yes, the process of the data traveling is very much simple. Simply it goes to the input node, then your hidden layer, and finally it goes to your output nodes. So this respective process which we are having up here, that's likely a very simple one. So that's the complete reason that why we say that this is the feed forward network is one of the simplest type of artificial neural network. Okay, and we have the another name as well for the neural for the feed forward networks, and that is the multi-layered network, MLN. Okay, so great, hope I am clear with that what is a feed forward network. So these networks are known as feed forward because the data travels forward in neural networks through input node, hidden layer, and finally towards the output nodes. And this one of the simplest type of artificial neural network is a feed forward network. And the another name for the feed forward network is multi-layered network, MLN. Okay, so great. Hope I am very much clear with this respective thing to you that what is a feed forward network. Now let's move forward with the next topic under this tutorial of back propagation. Now let's learn about that what are the key points of the back propagation. What are the key points which we have up in the back propagation? What are the points that you shall take care of? Let's discuss them about right up here. Okay. The very first key point for the back propagation is that there are two respective rules. First one is the power rule and the second one is the chain rule. So actually, a back propagation takes the advantages of these two rules, first of all. And what do these rules do? These rules permits the back propagation to work with the different number of outputs. So backpropagation takes up the advantage of these two rules, that is the power rule and the chain rule. And what do these rules permits or allows? So these rules are permits the backpropagation for working with a different number of outputs. This backpropagation, these respective rules, which are power rule and the chain rule, these permits the backpropagation. The very first key point which you should remember up here. Second goes for the error-prone projects. Whatever the projects which are in which you have to deal with the errors, whatever are the error-prone, in which basically there is some of the errors. Now, errors do not mean up here that syntax error or any indentation error. The error means here that there is a slight difference. There is a difference between your actual outputs and between your desired outputs. The difference between that is called as the error. Okay, so please do not relate these out with some syntax or some indentation errors. It's a sort of error in which what comes in which when you have up the difference between the actual output and between the desired output. Okay, so for these sort of project in which there is some error and with some like some difference between the actual and the desired outputs in the deep neural network, so especially onto that respective project, in that respective cases, this back propagation is very much useful. Okay, so the reason is that we have up the hidden layers. So in that hidden layers, the hidden layers adjust them and try to reduce up the errors which you are having up, right? We studied this when we discussed that how this algorithm works, right? There we discussed that the difference for the actual output and the desired output, first of all, is known as the error, and after that the hidden layers, whatever are the hidden layers, they kept on adjusting, they adjust, and the reason for their adjusting is that they try to reduce up the error. So that is the reason that back propagation is very much useful for the error prone projects. Okay, so for the projects which are dealing with the errors in that respective case, this back propagation is very much useful. Now, for developing the relationships between the input and the hidden layers. Okay, when you want to develop up the relationship between the input and between the hidden layers, so it's important for you to study about the group of input and the activation layers. So after the study of all of those respective things, then only it will be you will be able for the developing the relationship between the input and the between the hidden layers. What are the input layers? What are the hidden layers? What are the output layers? That all we did discuss up in very detail in some previous minutes, right? So, in the development of the relationship between the input and the hidden layers, you need to study the group of input and the activation layers. So, these are some of the key points of the back propagation that are really to be taken care of. First of all, there are two rules which are power rule and the chain rule. So what do these rules do? These rules permits the back propagation to work with the different number of outputs, and back propagation takes the advantage of these two rules for working with the different number of outputs. Secondly, if we talk about that what is the best case for applying of the back propagation algorithm, so the best case for applying and using the back propagation algorithm is the error prone projects in the deep neural network, in which there is some sort of error or that things are expected. So yes, in that backpropagation algorithm is the one which is essentially used. And third goes that for development of the relationships between the input and between the hidden layers, it's very much essential, it's very much needed for you to study the group of input and to study about the activation layers. Okay, so hope I am very much clear with all of these respective key points for the back propagation, which I did mentioned up here. Now let's move forward and let's discuss about some more things under the back propagation tutorial. So now let's learn about the advantages of back propagation. Since our last few minutes, we are learning about the back propagation, how it works, what are the things which we have up here. We learned about the feed forward networks. We did learn about the key points. Now it's the time for learning about the advantages of the back propagation. Okay, first of all, the very important advantage of the back propagation is that it's a fast and a simple and a easy to implement algorithm. Yeah, that's a so true thing actually. In back propagation, I did explain you out the algorithm for the back propagation, right? I did explain you. How much lines was it consisting? It was consisting only 3 to 4 lines of work, right? So that's the reason, first of all, that implementing the back propagation algorithm, it is very simple and easy. And now when the algorithm is short, then absolutely it's going to work there fast, right? So back propagation algorithm is fast, simple, and it's an easy to implement algorithm. These are the facts, these are the features which we have up in the back propagation algorithm, and the very first advantage of back propagation algorithm. Okay, so yes, that it is simple, it is fast, and it is easy to implement algorithm. Now, whatever the network we are having up in the back propagation, we are having up a flexible network. Okay, so that it means that whatever the previous knowledge we did have, okay, whatever the previous knowledge we did have regarding that particular network, now that respective knowledge is not at all required. Okay, so it's a sort of a flexible network. So whatever we were having the previous knowledge in regards to the network, so that respective previous knowledge is now not at all required. So that's the reason as well that we say it's a flexible network. It simply works on whatever the inputs are given to it, right? Now, okay. Now, next, there are no parameters to be tuned. Now, it doesn't work out with parameters actually. So there is no sake of thing for tuning the parameters and all those things. So we see that there are no parameters to be tuned. Okay, for the tuning, we do not require the parameters. Okay, and the back propagation approach which we are having up here, it works very well. It works very good in most of the cases. I did mention in the key points for the back propagation that for the error prone projects, this respective back propagation is the best algorithm which you could choose. So, in the same way, this respective back propagation algorithm, this particular approach, it works out very well in most of the cases. So these were the few of the advantages, like the back propagation is a simple, fast and easy to implement algorithm. It's completely a flexible network. It means the previous knowledge regarding the network is not at all required. There is no such thing for tuning of the parameters. The parameters tuning is not at all required. And this respective approach works very well in most of the cases. So in most of the cases, the approach of the back propagation works well in most of the cases, right? So these were the advantages which we are having up of the back propagation. Now let's discuss about the disadvantages of the backpropagation. Now I did mention of some advantages, but surely there are going to be some or the other disadvantages of the backpropagation. Let's discuss them out. The disadvantages of the backpropagation are that whatever the data we are having, the complete data is holded out by the input data. One of the disadvantage which you have up in the backpropagation, that the key to the overall data is holded by the input data. Like whatever the overall data you are having, that perspective is holded by the input data. Okay, now when we are dealing with the mini batches here, if I talk about the mini batch, so in that case matrix based approach is preferred. Now matrix based is one of the approaches which we are having up here. So for the mini batch, that perspective matrix based approach is completely preferred out. Right, so whenever you are dealing with the mini batches here in the back propagation, so in that respective case, matrix based approach is preferred out. Next, the inaccurate output can be led by the noisy data. If you are having up some noisy data, so in that case you could expect out some inaccurate output. Some inaccurate output can be expected in the form when you are dealing with the noisy data. So now these are the disadvantages of the back propagation which you are having up, that the key to the overall data is holded by the input data. For a mini batch, matrix based approach is preferred. Inaccurate output can be led by the noisy data. So hope I am clear with the disadvantages of the back propagation to you too as well. That what are the disadvantages? So advantages and disadvantage. If a respective thing is gonna have up some of the advantage, yeah, it is gonna have some of the other disadvantages as well, right? So hope I'm very much clear with that. Now let's move forward and let's see what are we having up next. So now we'll be seeing up that what's the practical and how do we implement up the back propagation algorithm. Okay, so let's get started out for that. First of all, the IDE which I'm using right now is one of the online IDEs, and that's the Google Colab. Okay, so you could simply use up this Google Colab IDE for writing your program, for writing up your code for the backpropagation algorithm. Okay, so right, for this I'm going to start up here, and first of all I'm going to give up some name for this file, because so that it may just suits out the thing. So backpropagation. Great, fine. So I'll be using this out, and just let me quickly zoom in a little bit so that it's the code is whatever I'm writing is visible to you at some sort of point. Yeah, pretty much clear. Fine. So this is the one which I'm going to use, and for the first, what I'm going to do is that I will be importing out my relevant libraries, whatever we are having, for writing up this particular code. Okay, so the libraries that I will be using up is NumPy, Pandas, Seaborn, Matplotlib, and I'll be using the sklearn.model selection. Okay, so from that, all of these respective things, first of all, I'll be importing up and giving up the short names for all of these respective libraries. Okay, so here I have to start off with that import NumPy as NP. Okay, my very first line. Secondly, I'm having import pandas as PD. Okay, my NumPy has been imported, my pandas has been imported. Thirdly, I have to import up the Seaborn, right? So it's import Seaborn as SNS. Okay, so the Seaborn library which we are having, I am importing that out, and rather giving that as well a short form which is SNS. Okay, further moving ahead, I am going to write up here import matplotlib.pyplot as pyplot as plt. Okay, so from the matplotlib.pyplot library, I am importing for the matplotlib.pyplot, I did give it a short form, that is PLT. Okay, and further I'm going to write up that from sklearn dot model underscore selection, from sklearn dot model selection. What is rather used up here for the import? So import up the import train underscore test underscore split. Okay, so these are respective things which I wanted to import. I will just connect this out here from my internet so that when you run up the code, it doesn't take too much of time in running. Okay, so great. NumPy and the pandas that I'll be using for the pre-processing of my data. Okay, for the Seaborn and Matplotlib that I will be using up for my visualization, and this is skill-ended model selection. I'll be using it for my backpropagation for training of my model. Okay, this is a complete idea. Now what to do is that you have simply to run up this respective code. For running up a respective line, what you have to do is that you have to either do enter plus shift. Okay, either you have to do shift plus enter, or simply here that this respective block comes, right, this respective cell, you will simply click on that and simply this as well runs out. So any of the method is there which you could choose according to your easiness, according to your sake of easiness. Okay, now next thing that goes is that what sort of data I'm going to use. I'm going to use one of the datas which are already present up into the Seaborn library. Okay, so I'm going to use up my data which is iris. Okay, and that is equal to pd dot read underscore csv. This is the way, this is the formula, sorry, this is the function which we use for reading up a csv file, right? So it's pd dot read csv, and into that we have iris.csv. Okay, iris is my respective data which I want to, iris.csv is my data. Okay, okay, 1 second. Okay, iris is equal to pd.read.csv, iris.csv. Okay, fine enough. Okay, let's do one simple thing. I would remove up and delete up this respective column. Okay, fine. What you have to do is that you have to first of all download up the iris.csv data and store that out onto our respective folders. Let's do that out very quickly. I would write iris data set download, right? Iris data set download, and from here you will be getting many of the respective websites from where you could simply download up the iris.csv data. Okay, let's open this out, and from here you could simply download that out. Other than that, the iris data must be present onto the Kaggle as well. So if you use that out, you would simply use that as well. So I'm gonna do this. Okay, what I could do is that I could simply actually take this link as well, Control C, and okay, let me get back right here and let's download up the file. Okay, so it will be downloaded up into the zip format, and from there it will actually be extracted up. Okay, so here, and yes, this is my data. Okay, now this is already into CSV format. I'm going to copy this out. Okay, I'm going to do the copy, and I'm going to simply save that onto one of my desktop. So in the desktop I have a folder which is data sets right here, and into that I'm simply going to paste that out. Fine. Now let me get back here, and from here I'm going to click on this folder. From this respective folder I'm going to click up for the first option, upload to the session storage, and from there I'm going to go to desktop, then I'm going to go to data sets, and from there I'm going to use up the iris data. So this is my data, and this respective data will be loaded up here for me, this iris.csv, and yes, here it is. If you want to see this data, you could see this out, and you could double click onto this one, and see onto the other side this respective data will open up for you. Okay, 10 entries per page. Fine. This is how you do out these particular things. I would close this out from here as well. Fine. Now let me quickly load the data. Now it will work. So iris is equal to pd, and I would close this out, pd dot read underscore csv, and my csv data is iris dot csv. Okay, and let's run that out now. Fine. Now it's successfully ran, and now what I'm going to do is that I'm going to write iris dot head. Okay, now what is this head function used for? Whenever you want to check out the roles for you, that what are the total number of rows into your respective like data. Sorry, what are total number of columns and the rows into your data? So into that respective case, you simply use up this hit. Okay, so it's restart hit. Now here I have that I have sepal length, I have sepal width, I have petal length, petal width, and the variety. Okay, these are respective things which I am having it up here. And next you could do the tail as well. So it is start tail. So it is gonna give you the last 5 rows, not the first, last one, right here. So this is the thing. Okay, it's a small data set which we are gonna take up here for the all of the things. Fine. This is pretty much clear. Now what I'm going to do is that instead of my wherever it is written Setosa, Virginica and versicolor, these are the 3 types of species which you're having up here. Okay. Now I'm going to replace those all with the numbers 0, 1 and 2. My next step which I'm going to do up actually here is this. Fine. So for that what I'll be trying up here is that I'll be writing up here iris. Okay. Putting up the large bracket and inside that I'm gonna add up the single inverted commas and here goes my species, my column name. Okay, and I'm gonna use up the dot replace function. Okay, and what to replace? First of all, what is gonna to be replaced? First of all, these are the ones. First one is Setosa, then we have Virginica. Okay, and then we have the versicolor. Okay, these are the things which are to be first of all removed out, so replaced out. And now what are the things from which these are to be replaced? It is to be replaced from 0, 1, 2. Okay, 0, 1. Okay, I'm gonna put up a comma and write up here in, okay, it will be in place is equal to, and I'm gonna set that as true. Okay, it's simply done. Let's simply run that out. Okay. It's species, species. Okay, let me check that out. Okay, instead of that, we have variety here. Okay, let's do that. variety, and is V small? Yeah, V is small up here. V small. Okay. Now let's run that out. Fine. So that's pretty much clear. Now I'm gonna do up one single more thing here. 1 second. I would not check up my data once again. So it is start, it's hit. Okay, let's run that out. Fine. So onto that case, simply now what has been actually changed up here is that I did simply did this respective thing at this particular place, right? Fine enough. Fine. Now let's move further here, and now what I am gonna do is that I am gonna write up some make one function for the training of my data. Okay. So it's dev, okay, dev2 underscore 1, let's say 1 underscore hot. In bracket, we have capital Y, okay. Now, into that, I'm going to declare ncall as one of my variables. And into that, I'm going to have the maximum value for Y. So, for that, I'm going to use up the function np.ax, okay. And into the bracket, I'm going to put up Y, and here goes my plus 1. Okay, next variable I'm going to make is that is binarized. Okay, my next variable that will be equal to np dot, it will be zeros. Okay, into the bracket here we have the length of y. Okay, we have the length of y, comma, we have the n underscore col, that is n underscore column. Find the other respective variable which we just made right above. Fine. Now, next what is required up here? Next further I'm going to write up the for loop. So for i in range, and in the brackets we have the length for y. Okay. For I in range, in bracket we have length for y. So here we have binarized. Okay, here we have binarized. Inter bracket we have I, comma, and I'm going to use up that y of I once again, which we did use up. Okay. And that I'm going to set it to here as 1. And further, after coming out of my for loop, I'm simply gonna return out the binarized. Okay, this is pretty much done. And now let's run that out. Fine. Further, let's move further here. And now what I'm going to do is that I'm going to define up a sigmoid function. Okay, So into that sigmoid function only we'll be doing up the further things, whatever are required. So now I'm going to write up diff, and my function is, let's say, sigmoid underscore func. Okay, and in the bracket I'm going to put up here as x. Fine. And now what I'm going to return up here is that I am going to return 1 by, and in the bracket 1 plus np dot exp. Okay. So right here further I'm going to write up np dot exp. Okay. And inside this exp I'm going to put up the bracket, and inside that I'm going to simply write out here minus of x. Okay, pretty much sorted. Fine. So 1 plus np dot ex in the bracket goes my this. Now I'll be writing up one more function. So let me make that function right here only, and then I could simply move forward with the things. Okay. Now into that respective case, now further what is required for the sigmoid function only. Now further I'm going to make up a function which is sigmoid derivative. Okay. So let's make that out very quickly. So here it's diff. Let me leave out one line. Diff, it will be sigmoid underscore, and that will be derivative. Derivative. Okay, Tive. Fine. Now into the bracket, what do I have? A diff. Okay, let me just get up some space here. Yeah, sigmoid derivative. Okay, and into the bracket, I'm gonna pass up here x. Fine. Let's put the colon. Get down. Here I have to simply return one thing, that is sigmoid function. Okay, sigmoid sig sigmoid underscore func. Okay, into the bracket we have here x. Okay, multiply that out by 1 minus, here we have sigmoid, 1 minus sigmoid underscore func. Okay, and into the bracket you have to put up as x. Fine enough, right? So the sigmoid derivative is completely done. Return the things which are to be returned up here, those are pretty much sorted. Now next comes, okay, I would just run out this very quickly. Fine, yes, it's completely okay. Now further I'll be making up a function which is normalize, and now that will be helping me in the normalizing of my data. Okay, so here goes diff normalize. Okay, and into the bracket I am going to put up the capital X. I'm going to set up the x's as minus 1. Okay, and the order will as will be set it up as 2. Fine. Let's get down, and here I am going to put up some variables like L2 is equal to, okay, it is np dot at least underscore 1. Okay, np dot at least underscore 1t, and further I'm going to use up the numpy array, and here I'm going to use up the linear algebra, LINEALG. Okay, this linear algebra function, and with the help of that I'm going to use up the norm, which is going to help me for the normalization. So x comma further order, and further we have here the x's. Fine, pretty much sorted. Further I have L2 is equal, L2 not like that, it will be L2 is equal to 0, and that so is equal to 1. Fine. And what next I'm going to return up here? I'm going to return up here the capital X divided by np dot expand underscore dims dimensions, and we have 12 comma, and I'm going to set up here the x's. Okay, simply done. Now this one as well I'm going to simply run out. Fine, very much clear. Next what I'll be doing is that I'll be having up all of my columns, and with that columns now I'm gonna do up some stuffs. Okay, so here I have first of all my columns. So here it is, 1 second. Okay, here it is columns is equal to, I'm going to put up all of the columns which we have. Just let me check that out very quickly. Sepal length, sepal width, petal length, petal width, everything in small. Okay, it's 1 second. Okay, it's sepal dot, okay, where is it? Okay, like this first of all, and here goes my sepal dot length. Okay, sepal dot length, here I'm going to put up a comma, then goes my sepal dot width, Then goes again my sepal. Sorry, it's not. It's time for the petal, right? So petal dot length. Okay, I'm gonna cross this out first of all. Okay, how come this bracket came up here? Right. Okay, so petal dot length is done, and after that, further I am having one more, and that is my petal dot width. Fine. So all of these fours are actually done up here, and now I'm going to write up here x is equal to pd dot read p. Okay, that is pd dot data frame. Okay, and into the bracket I'm going to put up here the iris comma, and for that columns is equal to columns. Fine. Further getting down, I'm going to set up the x once again. So in that case will be the normalized. So a normalized function we did already made up above. So for that I'm setting, and that will be x dot as underscore matrix and the brackets like this. Okay. Now further after that we are having up the columns. That columns is equal to, and here I have the variety, because variety was the column which we were having, right? Once let me check that out. Yeah, variety. Okay, so we have this variety here. Further now I'm going to do this for the y. So for y I'm going to write out pd dot data frame, and into the bracket I'm going to put up here the iris comma. I'm going to set up the columns is equal to columns. Okay, and for the y as well I'm going to set up normalize. Okay, not like this. It will be y dot as underscore matrix, and into the bracket simply it will be like this. Okay, now this thing is done. Further now I'll be again using y variable only. Okay, so it will be y is equal to, and now I'll be using up the function y dot flatten. Okay, y dot flatten. Done. And next will be y is equal to, I'll be calling up the function which we did use above. So it was 2 underscore 1 underscore hot, right? And into bracket we will be putting up a small y. Okay, up till this particular point I hope that it's very much clear, right? Now further what is needed, further the need is of the splitting of my training data sets. Okay, so further now what we'll be doing is that we'll be splitting up the data sets, and now further after the splitting everything would be done. Okay, so now I'll be splitting up the data to the training and the validation data. Now it's x underscore no, not like that. Yeah, I'll be writing that x underscore train. Okay, 1 second, let me simply run this out. Okay, in it got columns. Fine, let me check that. Columns is equal to, I guess it's columns is equal to columns. Data frame has no attribute as underscore matrix. Okay, so x is equal to normalize, and into the bracket we have x dot as underscore matrix, right? So let's check that out. X is equal to normalize, into the bracket you have x dot as underscore matrix. Okay, let's do out one simple thing. Let's comment out this respective line for now. Okay, and this one as well. Okay, let's now run that out. No attribute flatten. Okay, let me comment these two as well. Okay, fine. For now, let's just simply comment that out. Then we'll check out further that where the like at what place we just need to uncomment them out. Okay, great. Further, we'll be now be splitting up the training and the validation data. Fine. So it will be x train, comma, it will be x underscore test, comma, y underscore train, comma, y underscore test. Okay, and that will be equal to train underscore test underscore split. Okay, train and test split. Okay, into the bracket we have x comma y comma its test underscore size is equal to, I'm going to put up the size, it's 0.13. Okay, now I'll be making up a variable w0. Okay, so into that I'm going to use 2 multiplied by np dot random dot np dot random dot random. Okay, and further we are having 4 comma 5. Okay, pretty much done. And I'm going to set up here minus 1. Okay, so 4 will be my output. And okay, so in that case what we'll be having, 4 inputs and 3 outputs. That's the reason. Okay, for W1 I'm going to do up the same thing somewhat. So 2 into, we have np, we have np dot random np dot random, and into the bracket we have 5 comma 3. Okay, in the bracket we have 5 comma 3, and for this as well we are going to do out the minus 1. Fine. And here we are going to set up n is equal to 0.1. Okay, now further I am gonna do up some more things, like I'm gonna set up the error, and for that, into that we'll be putting up a range and further things will be applied out. Okay, now here I'm gonna put up the value for n. So n is equal to 0.1, right? And here from here it is my learning rate. Okay, and error I am going to set up as blank here for now. Okay, now goes my for loop. So for I in range, and you could put up a range according to, let's say I'm going to put up it as 1, 2, 3, 4, 5. Yeah, let's put that out this much of range. Okay. So now further, after writing up this for loop, let's move forward. Okay. Now what I'm going to do is that I'll be making different layers, and there, so I'll be using some different functions. Okay. This is what I'm going to do. So I'll be starting it from here. Layer is 0 is equal to, okay. So I'll be giving up different sort of variables, and onto that I'll be using different types of functions. So layer 0 is equal to, it will be x underscore string. Okay. Further. Okay. Further I'll be making my second variable, which is layer 1. Okay. And that too will be equal to my sigmoid function, which we just made, right? About sigmoid func. Okay, and into the bracket I'll be using up the dot function with the help of my numpy library. So it will be np dot, and here in the bracket it would be layer 0 comma, it would be w0. Okay, comma w0. Okay, great. Now further what I will be doing is that I'll be writing up here layer 2. Okay, that again will be equal to sigmoid. Okay, that again will be equal to my sigmoid function, which we just made it above, and that will be equal to np dot dot, and here will be my layer 1 comma w1. Okay, this is what it will be here for my layer 1 and for my layer 2. Okay, I need to do one thing. Actually, there's a certain time. After that time, the runtime gets out, and simply sometimes the runtime gets out, and your data which you did uploaded, that gets removed out from there. Okay, so I again need to go to my data sets, and from here I have to do for the erase data. Great. Now it will do that out. It actually loaded up my erase data, and what I have to do is that once I have to go up above, I have to run up all of my respective cells once again, because as I told that many a times it has the run out of the time. So when the time run out thing comes, so after that you will not be actually able to check up the things and all those respective ones. Okay, so onto that case, you have simply to be run again all of the cells. Now there's one simple function as well for running up all of the cells. Okay, I would let you know that particular as well. But if you just want to do that manually, so yeah, manually is as well allowed. You could just choose out anyone from your respective easiness. Okay, all of them have been run. You just go to here. Okay, here you have runtime, and click on runtime all. Okay, run all. So it will automatically run out all of the cells for you. This is the idea. Okay, let's get back to the program that we were writing up. Fine. So here this layer. Okay, next I am having up, now I'll be writing up the back propagation using my gradient descent. Okay, so here will be layer 2 underscore error. Okay, layer 2 underscore error, it will be equal to y train. Okay, y underscore train. minus, and then will be the layer 2. Okay, pretty much clear. Further, we are having layer 2 underscore delta, my second variable that I'm making. Okay, and that will be equal to my layer 2 underscore error. Okay, layer 2 underscore error multiplied by my sigmoid function, sigmoid underscore, it will be that derivative. Okay, multiplied by sigmoid underscore derivative, and into the bracket here we have the layer. Fine. Further, I'm going to write up layer 1 underscore error, my next variable, and that I'll be sitting with that dot function. I'll be applying up the dot function for this respective next variable. Okay, so onto that case, what I'm going to do is that I'm going to write up simply very quickly layer 2 underscore delta dot, and I'm going to write up here this dot function, and into the bracket I will be writing up here some sort of other things, like I'll be writing it up here variable which is w1 dot, and I'm going to use up this capital P. Okay, pretty much clear. Now further I have to use up my layer 1 underscore delta. So layer 1 underscore delta is equal to, now that will completely be equal to layer 1 underscore delta. Okay, yes, layer, okay, we just made up the delta for the layer 2. Layer 1 we haven't made up till now, right? So layer 1 underscore delta, and that will be equal to my layer 1 underscore error, okay, multiplied by sigmoid underscore derivative, okay, multiplied by sigmoid underscore derivative, and in the bracket I'm having layer 1. Okay, that's pretty much clear, I guess, right? So these were for a few lines actually, first of all, which you need to mention it up here. Now further we will be making two more variables, and into that also we will be using up the dot function. So let's do that out. W1, okay, it will be somewhat plus equal to, okay, now W1 plus equal to, here you have layer 1 dot T dot, and here you have my dot function. Okay, dot is somewhat making and multiplying of two numbers. It's somewhat like that particular thing. Okay, dot, and into the bracket I'm going to put layer underscore 2, and it will be delta s, and that too will be multiplied out by n. Okay, n was a variable which made up here, that is n is equal to 0.1, right? Multiplied with that. Next we'll be making W2. So again W2 as well plus equal to W2, sorry, it will be W0. Okay, plus equal to, and that will be again layer 0 dot T dot. I'm going to write up the dot function, and into the bracket we are going to use up layer, it will be layer 1 underscore, it will be the delta. Fine enough, and I'm going to multiply that with n again. Fine. Okay, layer 0, layer 1 dot, layer 2, layer 1 underscore delta. Pretty fine. Let's get down here, and now further what I'm gonna do is that I am gonna write up here the further things. Okay, that will be equal to my error. Okay, so my error will be equal to, okay, my error will be equal to my mean function of the layer 2 error. Okay, so np dot mean, inside that you have np dot abs. Abs is as well a function which is used up here. Okay, into the bracket further you have layer 2 underscore, you have error. So these are respective things which you are having up here, and error is as well calculated. One thing is left, here it is to be left out. Errors dot, and it will be append, and into the bracket what to append the error. Fine, let me run this out, and let's see that what is happening up here. Okay, invalid syntax, a dot. Okay, Oh, okay, this coming came inside here. 1 second, let me remove this out. Fine enough. Okay. Okay. The unable to force a frame shape must be 130 comma 1 given 130 comma 3. Okay. So here, right, we were writing up this particular thing. One thing has to be changed up here is that when I just wrote up the test size 0.13, so instead of that, it would be 0.33 actually. Okay, so this will be the size which we have to take here for writing out our code. Fine enough? Great. Now we'll be moving forward and we'll be now just writing up the rest of the things. Okay, so that we were already written up. Sorry, yeah, we just completed up this particular thing. Okay, so yeah. Now let's move on to the next line of our code and let's see further that what's gonna happen about here. Right. So now I will be having up a variable which is accuracy underscore t. Okay, this will be training. Accuracy underscore training is equal to. I'm gonna do 1 minus error. Okay, that will be ERROR. Okay, I'm gonna do 1 minus error, and I'll be multiplying that out with the variable with the number which is 100. Okay. Further, this is the thing which has to be done. Next, I'll be plotting up now my respective plot. So for that, I'll be writing PLT dot plot. And what I'll be plotting, I'll plotting up the errors. So into that, when I just wrote a plot, so in that case, a line plot is gonna come up as an output. Okay, so PLT dot plot, and into the bracket you have the errors. Fine enough. Then what the X label and Y labels you want to give? So PLT dot X label, and into the bracket you'll be having the X label as training. Okay. Next goes your PLT dot Y label. Y label. Okay. And that too will be your error. So X label will be the training and Y label will be your error. And at last here I have PLT dot show. So that respective this particular will be helping me to show out my respective plot for my output. Okay, this is what is actually done up here. Now, further after this particular thing, what is left out is that we simply have to do out one simple thing, and that is to print up a statement. So what that respective statement will be doing, that respective statement will be giving us the accuracy, that the training accuracy of the particular model. I'm going to run up all the cells at one single go because it will be more clear to you when we run up the cells at one single go. Okay, that's the reason I'm writing it out, and further we'll be running this. Okay, so here it goes my print statement, and inside that print statement we have to write up somewhat like that training accuracy of the model. Okay, the training accuracy of the model, I'm going to use up the plus sign, and here we have str, and I'm going to round that off, and into the bracket here goes my variable which is accuracy training. Accuracy underscore training. Yeah, accuracy underscore training. And now I'm going to put up a comma 2. Okay. And further, I could just put up a plus sign, and then I could put up a percent sign also. So it looks a little bit more better, right? So percent sign. Pretty enough. Fair enough, right? So now let's get down, and now further I have to do I have to write up the validations of the test. Okay, so for validating of the accuracy, so that will be done up here at this particular place. So let me get down here, please. First of all, so now it will be layer 0 is equal to, and that will be x underscore test. Okay, so layer 0 is equal to x test. Then we have layer 1, your layer 1. So now that will be equal to your sigmoid function. So sigmoid underscore func. Okay. Into the bracket you have np dot, and into the bracket you have your layer of 0 comma w of 0. Fine enough. Next, getting down here you have your layer 2. Okay, that will be equal to your sigmoid underscore func. Okay. Into the bracket you have np dot, and again here into the bracket you have layer 1 comma, here you have layer 1 comma w1. Fine, layer 1 layer 2 is in. Then we have the layer 2 underscore error, so that will be equal to your y underscore test subtracted by layer 2. Okay, getting down here, you have your errors. So E double R O R. Okay, so error will be equal to np dot mean, and into the bracket you have np dot mean, and into bracket you have np dot abs. Abs is the function. Okay, and into the bracket you have layer 2 underscore error. Okay, now next, getting down here, you have your accuracy validation. So accuracy underscore validation. Okay, accuracy underscore validation, that will be equal to 1 second. Yeah, that will be equal to 1 minus, and here we have the error. Fine, multiplied by, here we have 100. Fine, and at last I'll be printing up a last statement, that is print here will be validation accuracy of the model, plus here we have the str of and I'm going to round that off, and into bracket I could simply put up accuracy underscore validation, comma, round off up till 2 decimal places, and plus I could put up a simple percentage sign. So this perspective, here I completed up writing up my complete code for the back propagation algorithm. So right, I guess that you are having now a very pretty clear idea that how do we write up a back propagation code, and what are the things that are included, and how are the things actually gonna be, and how are the things actually written up here. Right, so hope this thing is pretty much and very much clear to you regarding the writing of the back propagation. Actually, how do we implement of the back propagation with the gradient descent? Hope that is very much clear to you, right? Okay, so now it's the summary time. Let's discuss about the complete tutorial which we have discussed. Let's take up a quick recap of all the topics which we discussed so far. Let me take you to the very starting from where we did started out. So we started out that what is a back propagation. So we did see that first of all, back propagation it plays up a very essential part in the neural network training, right? So back propagation, it's a process in which we obtain the previous iteration for a fine tuning of the error rate, which is based onto the neural net, and that correct and proper tuning of the weight, it helps you to lower up the error rates, and the model is made reliable by increasing of the generalization. So these were the things which we did saw under this back propagation, that into this the model is made reliable by the increasing of the generalization, and the correct and the proper tuning of the weight, it helps you to lower up the error rates. Next, how does the algorithm actually work? So how does this algorithm work? So in this respective back propagation, we have 3 main layers. Okay, the first one is the input layer, second goes your hidden layer, and third is your output layer. The 3 different types of layers we are having up here in the back propagation. So how do these work? So what we have up here, that the input layer which we are having, that receives up the X. Okay, after that, the input which we are having, that is modeled with the weight, that is the W. Okay, that is your hidden layer. Now, each and every hidden layer calculates the output, and the data is ready at the output layer. Now, whatever the hidden layers, so ones which you are saying with the help of dotted, those are hidden layers. So whatever the hidden layers we are having up here, these collect and the data, and this is like processed for the output layer. Okay, and the error is the difference between your actual output and between your desired output. So that's the thing, that's the difference which you are having between your actual output and between your desired output is known as the error. Okay, now what we do, So we, after this, all of the sorted things are done, we go back to the hidden layers and adjust the weights so that this respective error is reduced in the future runs. So in the future run, whatever the error we are having, so as to reduce that out, we go back to the hidden layer and adjust up the weight. Now, this respective procedure is repeated up till the point we get the desired output. The training phase is done under a supervision, and once the model is stable, it is used up into the production. So this is how the backpropagation algorithm actually works. Next, we are having that what is back and forward propagation. So we did saw for the forward that it is a process to move from the input layer to the output layer in the neural networks. So moving from input layer that is onto the left to the output layer that is onto the right is in the neural networks is known as the forward propagation. And moving from the output layer that is onto the right to the input layer that is onto the left in the neural networks is known as the backward propagation. So for the intermediate variables in neural network, for the calculation and for the storage from the input to the output layers, these are the things which are done. Now, what is a feed-forward network? So first of all, we did have a new name, another name actually for the feed-forward network, and that is a multi-layered network. Okay. Now, these networks are known as the feed-forward. The reason for them is that the data travels forward in the neural networks through the input node, then goes the hidden layer, and finally it travels to the output nodes. So this smooth procedure, that is the reason we see them as a feed-forward network. And one of the simplest type of artificial neural network is a feed-forward network. Okay, one of the simplest type of the artificial neural network is the feed-forward network. Then we learned about the types of the backpropagation network. So we discussed two types of backpropagation network. First one is your static backpropagation and second one is your recurrent backpropagation. So in the static backpropagation method, mapping of a static input generates the static output. This is what was happening up in the static backpropagation. And in the recurrent backpropagation, this is respective is conducted up till the certain threshold is met, and after that the error is calculated and it is propagated backwards. This is what happens up in the recurrent backpropagation. Now, what are the key points of the backpropagation? So in backpropagation, it picks up the advantages of the two rules which are named as bar rule and the chain rule. And what it does, it actually permits the backpropagation to work with the different number of outputs. Okay, so that is the reason it takes up the advantages of these two rules. Second, for the error-prone projects in the deep neural network, the backpropagation is very much useful. So when we deal with the error-prone projects in the deep neural network, the backpropagation is very much useful in that case. Next, for developing up the relationship between the input and between the hidden layers, you need to study the group of input and the activation layers. So these were the key points which we did have for the backpropagation. Advantages. So yes, it's fast, simple and easy to implement. It is flexible network. There are no parameters which are to be tuned, and this respective approach works very well in most of the cases. And if we talk about the disadvantages, so the key to the overall data is halted by the input data, one disadvantage. Second, for a mini batch, matrix-based approach is preferred. Second, a disadvantage, and inaccurate output can be led by the noisy data. The third disadvantage, right? So, hope you are very much clear with all of the things which I did mention up under this respective tutorial for the back propagation. Hope you got to know about all the important information regarding the back propagation. So this is all for this video. Till then, thank you and take care.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions, and I will respond to your comments.